All right. So welcome to second semester dual credit pre-calculus. This is M126. We're going to be focused a lot on trigonometry this semester. Like I said a couple minutes ago, so if you just joined us, you probably didn't hear me say this. We're going to start chapter 6 today. We're going to begin talking about angles. I'm going to go ahead and share my screen so that you can see what I'm seeing. There we go. All right. If you guys wouldn't mind letting me know in the chat whether or not you can see my screen now, I would greatly appreciate that. Awesome. Get this all set up here. Once I share my screen, it messes everything up. Okay. So just very quickly, class policies. When I actually see you guys in person, I am fine with you choosing your own seats. Once you pick a spot, I do ask that you stay there at least through the first test. We do have to have a seating chart in the event that we would need to do any kind of contact tracing. If you pick a spot and after a couple of days, you're like, this just isn't working for me, just let me know that you want to move and where you're going to move to. I just need you guys mostly in the same spot, at least chapter to chapter. If you want to move around in between, that's fine. If there are any issues with choosing your own seats, I might need to move some people around, just depending. There's some different needs. I'm not anticipating any problems with you guys choosing your own seats. I didn't have any trouble last semester. If you have not had me before, hi, I'm Ms. Bolt. Several of you I have had last semester, and so hopefully things go well again this semester. One, I do want to show you an assignment that is due tomorrow. Very simple. Those of you that had me last semester, I had this one last semester as well. It's this introduction video. This one is due tomorrow. The 6-1 homework isn't going to be due until Wednesday. We'll talk about that one a little bit more towards the end of class. But this introduction video, I did want to go over with you real quick. So you can get to this either by clicking on the link down here. That is on our daily page. So our class Canvas page, you would scroll down until it says click here for today's lesson just underneath the Zoom link. You'd click on that. That takes you to our daily page, which is this right here. Tells you what we've got going on that day. I'll have the notes preloaded here. And then any homework assignments would be down at the bottom. Like I said, you can also access those from the assignments tab over here. I'm going to click on the introduction video assignment because this one is due tomorrow. So I want you to clearly say your first and last name. And if you have a preferred name that you would rather I use, go ahead and let me know that in the video as well. That way, when I do get to see you guys face to face, hopefully I can pronounce your name correctly. Tell me how you felt about first semester pre-calculus. And then after you have done those two things, pick out 4 of the following things just so that I can start to get to know you a little bit better. If I had you last semester, I'm sure there's still plenty that I can learn about you that we didn't have a chance to find out about last semester. So if you guys have any questions for me about the introduction video assignment. All right. If you have no questions there, then we're going to go ahead and start the notes for 6.1, which is going to be all about angles. Let me go ahead and make that full screen. There we go. All right. So beginning our discussion of angles, I want to talk about some terminology here. Right angle. What do I mean by a right angle? What is the definition of a right angle? You can type it into the chat, or you're welcome to unmute your mic if you would prefer. Absolutely correct. This is an angle that is exactly 90 degrees. It is exactly half of a straight angle. Straight angle being 180 degrees. Absolutely, Pedro, you're correct. It looks like an L. So when I said half of a straight angle, what do you think I mean by a straight angle? Or why do we call a 180-degree angle a straight angle? Yes, straight angle is a line. So then what would an acute angle be? Less than 90. Less than 90. So 90 degrees would be its upper bound. Does an acute angle have a lower boundary? Has to be less than 90. Does it have to be greater than anything in order for it to qualify as an acute angle? Yes, that's absolutely correct. Has to be greater than 0. So an acute angle is an angle that is between 0 degrees and 90 degrees. Or another way to write that would be 0 degrees and to 90, like this. All right. What about an obtuse angle? What would the lower and upper bounds for an obtuse angle be? Yes, an angle that is between 90 and 180. So in between a right angle and a straight angle, or another way to write that would be like this. Before we talk about complementary and supplementary angles, I want to take just a brief moment and talk about these guys right here. Does anybody remember from geometry what we call that symbol right there? Anybody remember from geometry what we call that symbol? Yes, that's absolutely correct. That is a theta. We will often use Greek letters for angles. So some of the more common ones, theta gets used a lot. A lot of times you'll see alpha. We'll use beta quite a bit. So hopefully you're familiar with those three. There's two others that often get used as well. They are gamma and phi. So those are some of the more common Greek letters that we will use for our angles there. And I wanted to take a moment to talk about those because as they show up in different problems, I didn't want them to take you by surprise. Okay, so now that we've talked about those, can you guys tell me, what do I mean by a complementary angle? What is a complementary angle? Two angles that add up to 90 degrees. Absolutely correct. Two angles whose measurements add up to 90 degrees. Or another way to write that exact same idea would be alpha plus beta equals 90 degrees. All right, so if that is what complementary angles are, what is supplementary? Same exact thing, except for 180, absolutely correct. So two angles whose measures add to 180 degrees, or alpha plus beta equals 180. Fantastic. I want to give you guys a moment to make sure that you have all of this written down, and then we are going to start talking about some more precise ways to measure angles. Grab a screenshot if you need to. Okay. So if I want to measure with more precision than just an angle, like when I'm measuring distances, we have lots of different units of measurement for distances. We've got miles, we've got yards, we've got feet, we've got inches, we have parts of inches, fractional portions, or with the metric system, we've got kilometers, we've got meters, we've got centimeters, we've got millimeters, nanometers. We can measure into very small, precise parts. How do we do that if an angle measurement falls in between two whole number degrees? And the answer to that is we've got two different ways of measuring those. We have decimal degrees, and then we can also measure in degrees, minutes, and seconds. This is precision that gets used a lot. So first, let's talk about notation. Notation for degrees, that's my little circle. Notation for minutes is just one little tick mark. It almost looks like what we use to represent feet. And then seconds, we use two little tick marks, kind of like what we use for inches. When we're converting between these, 1 degree is equal to 60 minutes. One degree is equal to 60 minutes. One minute is equal to, does anybody want to take a guess? 1 minute is equal to how many seconds? You're probably right. 1 minute, yes, that's absolutely correct. 1 minute is equal to 60 seconds. Using degrees, minutes, and seconds gets used a lot in navigation. So if I wanted to express these angles, getting them to the nearest second using degrees, minutes, seconds, the first one is already precise. This one, theta equals 90 degrees. It doesn't get more precise than that. For the second one, Any whole degrees I want to keep as whole degrees. It's the fractional part, the decimal part, that I would want to change into minutes and seconds. So for this middle one, theta equals, I have 54 whole degrees. And then I need to take this decimal portion right here. So I have 0.1269 degrees. I want to change that into minutes. Well, 1 degree is equal to 60 minutes. So that would be equal to 0.1269 times 60 minutes. Grab your calculators, multiply those together for me, that 0.1269 times 60, and type into the chat what you get. .1269 times 60. Thank you. We got 7.614. And that would have the unit of minutes on it. What's the whole number portion of that? 7. So I'm going to grab the 7. So 54 degrees, 7 minutes. And now I'm going to take the decimal portion of this right here, that 0.614. So 0.614 minutes. I want to convert that into the more precise unit of seconds. So 0.614 minutes would be equal to 0.614 times 60 seconds. Go ahead and type that into your calculator. Like I said before, cell phone calculator is fine. Type that into your calculator and then tell me in the chat what you get. Thank you, Brendan. You got 36.84. That is seconds. We said we were supposed to round this to the nearest second. So what would I want to round this to? $37. Round it to 37 seconds. Absolutely. So 54.1269 degrees is equivalent to 54 degrees, 7 minutes, 37 seconds. I want you guys to do the third one up there on your own, following the exact same pattern that we just did here. I'm going to give you guys about 2 minutes or so to do that on your own, and then we'll check your work against mine. So to answer the question in the chat, the minutes aren't being rounded down. We're taking the decimal portion of the minutes and we're converting it into a more precise measurement rather than having a decimal portion there. It's kind of like the difference of if you're measuring something in centimeters, you could say it's between 5 and 6 centimeters, or you could say it's 5 centimeters and 8 millimeters. You'd be more precise doing it that way. Does that make sense? You're absolutely welcome. Okay, so let's go over this last one here. So theta, and I see, Brendan, you're absolutely correct. You should have gotten 126 degrees. Again, you grab the whole number for the degrees right here. And then you should have gotten 34 minutes and 17 seconds. So just like before, you would be grabbing the decimal portion and converting that into the more precise minutes. 0.5714 degrees is the same as 0.5714 times 60 minutes. And when you do that, you get 34 whole minutes and then 0.284. So you grab the 34 whole minutes, that goes to become part of your final answer. And you take this 0.284 minutes, you convert that into seconds, 0.284 times 60 seconds. When you do that, you get 17.04 seconds. And since we're supposed to round this to the closest second, we're just going to round this to 17. You guys have any questions for me about this portion, about going from decimals into degrees, minutes, degrees, minutes, seconds? Yes, I said that the right way, and then I got confused. If you have any questions, ask them now, because we're getting ready to go the other way. We're going to go from degrees, minutes, seconds into decimals. All right. If you think of any questions, please let me know in the chat. Just because I've moved on doesn't mean that I'm not willing to answer questions that come up. Okay. We're going to express each of these angles as a decimal to the nearest 10,000th of a degree. So before we actually do this, tell me, how many decimal places are we going out if I want it to be to the nearest 10,000th of a degree? How many decimal places are we going out? Absolutely correct. We're going to go out 4 decimal places. Okay, so another way to think about these, rather than 17 degrees, 46 minutes, 13 seconds, I have 17 degrees plus 46 minutes plus 13 seconds. If I want to change it from seconds back into minutes, what operation would I use? I know it has to do with 60. Division, absolutely. We're going to divide this by 60. So 17 degrees plus 46 minutes plus, if I change this to be 13 over 60, that will change that into minutes. What is 13 divided by 60? What is 13 divided by 60? Absolutely correct. Okay, so I'm going to write down the abbreviated version of what I saw. So I would have, I'm going to add that to the 46. So 46.21 and then 6 repeating. So 2167, 2166. I'm going to write it down like this for right now. And that would be minutes. What do I do to the minutes to convert it back into degrees? What do I do to the minutes to turn it back into degrees? Divide again. We're going to divide by 60 again. So 46.216 repeating divided by 60 is going to turn this back into degrees. And what would I get then when I divide that and then I add the 17 whole degrees to it? What would I get? Remember, we want to round it to 4 decimal places. 17.7703 is absolutely correct. If you wrote that as 17.7702, I'm not going to count it wrong if your very last digit rounded out to 4 decimal places is 1 away from mine. That should be fine. I want you guys to do the second one on your own. Same exact process as we did over here, changing it from degrees, minutes, seconds into just decimal degrees. I'm going to give you guys about 2 minutes to do that. When you have an answer, go ahead and type it as a direct message into the chat so that only I can see it. Brendan, that's correct. Pedro, that's correct. Jay, that's correct. Max, that's correct. All right. You guys notice? Oh, got it. Thank you for the update there. I wasn't sure because I saw you had joined Carrington before, so I wasn't sure exactly what was going on. Did you guys notice anything interesting when you change this into just decimal degrees? Anything interesting that you noticed happen? Anything that would be different or unique from before? Yes, it was 1 bigger because the minutes were over 60. The number of degrees actually increased by 1. Most of the time, we don't have minutes that are going to go bigger than 60 because if you have more than 60 minutes, that would add a whole nother degree. Nice observations there. I'm glad you guys picked up on that. So this would be approximately 63.6833 minutes. We take that and divide it by 60 and add it to 72. To change it back into just solidly degrees, and we get 73 0.0614 degrees. If that's not what you got, I hope that you guys were able to find or pick out where your mistake happened. All right. Complementary and supplementary angles. We're going to start off with an easy one, and then we're going to move into some rather interesting ones. We want to find an angle that is complementary, and then another one that is supplementary to our given angle theta. Remind me one more time, complementary angles do what? How do I know if two angles are complementary? They add to 90 degrees, absolutely. So I could say theta plus alpha equals 90 degrees. What about supplementary? Remind me on that one also. Add to 180, so theta plus alpha equals 180. I'm going to change that to a beta just to be a little bit different. Theta plus beta equals 180 degrees. All right, so for the first one, we want to find complementary and supplementary. Part A over here, we've got 23 degrees. If I have my angle theta, and I want to find the angle that is complementary to it, I can do 90 degrees minus theta, and that will give me my angle alpha. So if I do 90 degrees minus my given theta is 23 degrees, what would be complementary to 23 degrees? $67 degrees, yes. And then for supplementary, very similar process. Instead of 90 minus theta, I'm going to do 180 minus theta to find my angle beta. So 180 degrees minus 23 degrees. And I have an answer in the chat here of 157 degrees. That's absolutely correct. Now I want to take that and I want to be able to do it with degrees that are written not as whole degrees or as decimal degrees, but ones that are written as degrees, minutes, seconds. So that's why I kind of started off with a whole number first. I know that for them to be complementary, I want to take 90 and I want to subtract the angle that they gave me. A whole number and subtracting something where it's not all written in the same unit is a little bit confusing. So I'm going to take 90 degrees and I'm going to rewrite that in an equivalent form that's going to have all three of those units so that I can match up my like terms and I can subtract them that way. So instead of writing 90 whole degrees, I could write 89 degrees. That leaves me 1 degree short, right? How many minutes would make up that next whole degree? How many minutes would it take to take that up to 90 degrees? 60 minutes. So I could write this as 89 degrees, 60 minutes. But the problem there is that my angle theta is written in degrees and minutes and seconds. So I'm going to kind of break this down just a little bit. Hold on, I'm going to back it up for a minute. 89 degrees, 60 minutes. This is equivalent to 90 degrees. I want to think of another way to write something that is equivalent to 90 degrees, but has degrees, minutes, and seconds there. So I'm going to keep this 89 degrees. Instead of writing 60 minutes, I'm going to write that as 59 minutes. There we go, 59 minutes and 60 seconds. This is also equivalent to 90 degrees. So if I rewrite it like this, now I can subtract my theta pretty easily to find my angle alpha. So if I did 89 degrees, 59 minutes, 60 seconds, minus our angle theta is 54 degrees, 31 minutes, 10 seconds. What would my complementary angle be? What would my complementary angle be? $35 degrees. We do 89 minus 54 to get to 35. 28 minutes, 59 minutes minus 39 or 31 minutes, and 50 seconds. Oh, I put minutes on the 20, or put too many marks on my 28 minutes. 50 seconds. There we go. So there's my complementary angle. I'm going to use a very similar process to find the supplementary angle. Can you guys tell me an equivalent way of writing 180 degrees using degrees, minutes, and seconds? What would be an equivalent way that I could write 180 degrees so that I'm using degrees, minutes, and seconds? Yes. I can rewrite this as 179 degrees, 59 minutes, 60 seconds. Because that is equivalent, that is the same as 180 degrees. All right, so let's do that. I'm going to do 179 degrees, 59 minutes, 60 seconds. We're going to subtract our angle theta, 54 degrees, 31 minutes, 10 seconds. What would my supplementary angle be? What would my supplementary angle be? Close, Brendan. Very, very close. There you go. Yes, perfect. It's going to be 90 degrees bigger than our complementary angle, so the minutes and seconds are going to stay the same. This is going to be 125 degrees, 28 minutes, 50 seconds. Beautiful. I want you guys to do the third example, part C, on your own. I'm going to give you guys about 2 minutes or so for that. And then we are going to compare. just like before, when you have an answer, type it into the chat for me.
Miss Bolt, can you go back to the previous slide real quick?
Yeah. This one back here?
Yeah.
Oh no, I just now saw that. My apologies.
It's good. Okay, I got it down now. Thanks.
You're welcome. And Brendan, you are absolutely correct there. All right. So our complementary angle. There we go. Good job, Miles. Complementary angle is going to be 8 degrees, 10 minutes, 4 seconds. And then our supplementary angle is going to be 90 degrees bigger. So 98 degrees, 10 minutes, 4 seconds. Awesome, awesome, awesome. All right, we're going to stop there for today. And I do want to look with you real quick. Your 6-1 homework, if you didn't have me last semester, I do almost all my homework on Canvas. And I give an unlimited number of attempts on the homework. This 6-1 homework is completely auto-graded. You have an unlimited number of attempts on it. It is due on Wednesday. Introduction video is due tomorrow. 6-1 homework is due Wednesday by midnight. You can go ahead and get started on it if you want to, but we still have more than half of 6-1 to finish up. So if you want to hold off and start that tomorrow, that is totally fine. I hope you guys have a fantastic rest of your day, and I look forward to seeing you guys hopefully in person tomorrow. Have a good one, everybody.